Hi everyone. Today we are going to solve a question on dissipated powers by light bulbs. Let's read the question. The light bulbs and batteries in the two circuits are identical. Compare P1, the total power dissipated by circuit 1, with P2, the total power dissipated by circuit 2. To calculate the dissipated power in a circuit, everybody perhaps knows that the equation for power, it is equal to either V times I, where V is the voltage and I is the current, or you could use V squared over R. Again, V is the voltage, and R is the resistance of the light bulb, or R I squared. So you could use either of the three equations in order to calculate the power dissipated by a light bulb. But if you remember in our exam prep session, I said the best way to calculate the power dissipated by the light bulb is to use basically V squared over R. It would be so dangerous to use R I squared as the power dissipated. It could get very confusing. Let's say somebody is interested in using P equals RI squared. So if I take the current inside, the current coming out of the battery of the first circuit, and I call it I, and also if I take the current coming out of the second circuit's battery, and I call it I, you may think that the power dissipated for the first circuit would be I squared R. Yes, because the light bulbs are the same. They all have the same resistance R. And for second circuit, you would say, oh, the power dissipated. I have two light bulbs, so therefore I will have 2I squared R. 2I squared R. Therefore, if I call the power dissipated in circuit 1 P1 and for circuit 2 P2, therefore P2 would be bigger than P1, and the answer would be A. And this is absolutely wrong. Why? Because the current coming out of the battery in circuit 1 is not the same as the current coming out of the battery in circuit 2. I'm going to call the current for circuit 1 I1 and for circuit 2 I2, and I'm going to prove to you that these two currents are not the same. Okay, so my power, I cannot calculate the power basically using the formula that I wrote. So, if I look at the total resistance of circuit 1, the total resistance is R because I only have one light bulb. And if I write the equation, the total voltage equals the total resistance times the current I1, and I isolate for I1, you will see that I1 equals V over R. For circuit 2, if I want to write Ohm's law, V equals Ri, and I look at the circuit and I see I have two light bulbs and they are connected in series. Therefore, we know that the total resistance is equal to 2 times R, R plus R. Now, if I write Ohm's law, I have V equals V total, which is the same as the voltage of the battery, equals R total, which is 2R, times I2. You see that I2 equals V over 2R. So you guys see that I1 and I2 are not equal. Therefore, it's quite difficult to use P equals R I squared in order to compare the dissipated power. As I mentioned in the exam prep session, it is the best to use V squared over R to calculate the power dissipated in the circuit. So if I look at circuit 1, and I'm going to use V squared over R, if I look at circuit 1, for circuit 1, the power dissipated P1 is going to be equal to V squared. The voltage across that right bulb is the same as the voltage of the battery and is equal to V squared over R. I mean the power. So P1 equals V squared over R. Now, if I look at circuit 2, for circuit 2, the power dissipated in light bulb 1, let's say the top bulb, it would be V squared over R, but V across that light bulb on the top, it's not the total V. Because the two resistors are in series, the battery's voltage, it will be divided. It will be divided to two voltages, V over 2 and V over 2, to two equal voltages. So therefore, we have V over 2 here and V over 2 in the bottom. Because they are in series, the voltage will be divided. Now, if I want to calculate the total power, I add the power dissipated in each light bulb, and I get the total power. So P2 would be the total voltage, the voltage across light bulb in the top branch, that would be V squared over 4, because V over 2, if you square it, it would be V squared over 4. So I have V squared over 4R plus V squared over 4R. If you add these two fractions, you will get V squared over 2R. So you guys see that actually P1 is bigger than P2, because P2 is half a P1, and therefore the answer would be C.